Dr. Amina Patel sat alone in her tiny kitchen, the only light coming from a single overhead bulb that cast stark shadows across the linoleum floor and the stacks of scientific journals piled on the table. She unfolded the Global Health Foundation's rejection letter with trembling fingers, the heavy cream paper crackling under her touch. The embossed logo at the top, two interlocking hands forming a heart, stared back at her ironically, as if mocking the months she had poured into her proposal. She'd spent countless late nights drafting a fellowship application that detailed a novel gene-editing approach for a rare pediatric syndrome, believing wholeheartedly that her work could redefine treatment paradigms. Now, the words "fell below threshold" seemed to erase every experiment, every statistical analysis, and every sleepless evening spent balancing pipettes and patient data. She pressed the letter flat against the table, her eyes tracing the curt phrasing again and again. No feedback, no critique, only a sterile form letter that spoke of competitive selection and limited funding. Around her, the kitchen bore the remnants of her academic life. Empty coffee mugs stained with grounds, a whiteboard on the wall scrawled with flowchart diagrams of CRISPR constructs, and an open laptop displaying code for gene sequence analysis. Each item felt like a testament to effort unrecognized. Her shoulders tightened, and she bowed her head for a moment, grief pooling in her chest like lead. The weight of that disappointment was more than professional. It felt personal, a message that her contributions, her identity as a woman of color in science, still weren't enough to overcome institutional bias. As she rose to pace the cramped space, the letter fluttered to the floor. She kicked aside a metal chair, sending it clattering into the wall, then paused before a shelf of family photographs. There, in a picture from her graduation day, she was beaming in a cap and gown outside the lecture hall where she'd defended her dissertation. Beside her stood her parents, immigrants who had sacrificed everything so their daughter could pursue her dreams. She recalled her mother's trembling joy and her father's proud nod when she first spoke of harnessing gene therapy to heal children born with debilitating disorders. Their sacrifices had been vast. This rejection felt like a betrayal of their dreams as much as her own. She sank back onto the chair, pulling the hood of her sweatshirt over her head. Rain began tapping at the window panes, its steady rhythm a counterpoint to the thunder of her thoughts. In their sound, she heard both sorrow and resilience. Her mind raced through the litany of experiments, the days spent coaxing stem cells to differentiate, the nights deciphering protein interactions under a microscope's glow. She remembered the breakthrough moment when a fluorescent marker revealed a promising gene activation pathway, and how she had danced alone in the lab, heart pounding with the promise of discovery. That memory surged now as a small ember of resolve. Straightening, Amina reached for her notebook, a battered volume whose pages held the sorrows and triumphs of her journey. She opened to a blank spread, uncapped her pen, and wrote in precise script, "This is not the end." She sketched a new to-do list: refine the data, seek alternative funding, share preliminary findings at a local symposium. Her breath came steady now, purpose replacing despair. Around her, the kitchen light glimmered on the notebook's fresh ink. In that moment, Dr. Amina Patel vowed to transform rejection into the catalyst for her most audacious work yet, one that would ensure no child faced this syndrome without hope. Dr. Amina Patel stood in the center of her one-bedroom apartment, the morning sunlight filtering through dusty blinds and illuminating a scene of organized chaos. The spare room, once a storage closet, had been transformed overnight into a makeshift laboratory. She'd shoved aside old camping gear and discarded cardboard boxes to clear space for a scuffed metal workbench, its surface crowded with second-hand pipette racks, a battered hot plate, and a borrowed microscope whose high-powered lens gleamed under a desk lamp clamped to the edge. Along the far wall, a narrow folding table held rows of reagent bottles, some labeled in careful, looping handwriting, others taped over with sticky notes reading "Do not use," until she verified their contents. Beneath the table, plastic bins overflowed with test tubes, Petri dishes stacked like thin saucers, and packs of sterile gloves in various sizes. A cheap mini refrigerator in one corner hummed softly, its door plastered with reminders: store CRISPR mix here, and patient samples, do not discard. Amina moved with deliberate efficiency, filling a clean glass beaker with filtered water and using it to rinse her hands before donning a crisp nitrile glove. She slotted a worn-in lab coat over her sweater, the pockets already heavy with blue ink pens, notepads scribbled with experimental hypotheses, and a slim UV flashlight for scanning gel electrophoresis results later that night. On the windowsill, she'd arranged a single potted succulent, a gift from her graduate advisor, a quiet reminder that even in this cramped space, life could flourish under the right care. She retrieved a microcentrifuge tube from a rack labeled Day 2 Runs, carefully pipetting 20 microliters of her latest cell culture supernatant into each tube. The cells, genetically edited to express a fluorescent marker when the novel protein cascade activated, had shown promise in her initial screening. Now she needed to quantify expression levels using a plate reader rented by the hour from a nearby community lab. Time was her enemy. Each hour the plates sat unrefrigerated increased the risk of degradation. As she capped the tubes, her laptop beeped with a new email notification. She swiveled to the cluttered desk where the laptop perched atop a stack of journal articles. The screen displayed a notification from her undergraduate mentee. Just sequenced the new CRISPR construct. Data looks good. Amina allowed herself a small, tired smile. This apartment lab might be improvisation, but it was also a crucible for mentorship and discovery. She grabbed her coat and stepped into the narrow hallway, carefully balancing the rack of tubes. The building's linoleum floor creaked under her weight, and neighbors' muffled morning conversations drifted through thin walls. At the elevator, she tapped her key card, borrowed from her former advisor's lab, and rode down to the underground garage. The rented sedan's trunk was already loaded with 2 duffel bags, one containing the portable microcentrifuge she'd bought at auction, the other holding insulated cold packs for transporting her precious samples. As she drove toward the community lab, Amina rehearsed the day's schedule in her mind: a 2-hour slot on the plate reader, a meeting with a potential collaborator in molecular bioinformatics, and a late afternoon run to the nearest supplier for fresh reagents. The city's skyline glinted through her windshield, each glass tower a reminder of the institutional walls she was determined to breach. Pulling into the lab's designated loading zone, Amina felt a familiar surge of purpose. The makeshift apartment lab was only the beginning. Here, she would translate her small-scale successes into data robust enough to demand the attention she'd once been denied. As she unloaded her gear and strapped her sample rack into the back of the lab's centrifuge unit, she steadied her breath. In this borrowed space, amid orders of plates and hum of equipment, Dr. Amina Patel pressed forward, driven by the conviction that true discovery could spring from the humblest of beginnings. That evening, long after the building's lights had dimmed, Amina returned to her apartment lab to review the day's data under the glow of her desk lamp. The thin slip of paper taped beside her microscope read Run 14, Stain Protocol Revision, a reminder that tonight she would test a slight tweak in her immunofluorescent assay. She retrieved Run 14's samples, petri dishes of cultured patient-derived cells, and placed one under the microscope's stage. Her protocol called for a primary antibody that bound the target protein, followed by a fluorescent secondary antibody. But in her fatigue, she had inadvertently swapped the dilution steps. The secondary antibody had been applied at full concentration, while the primary had been overly diluted. Normally, she would have discarded the plates and started anew. Yet tonight, curiosity held her back. She positioned her eye to the eyepiece and flicked the excitation switch. The field of view erupted in unexpected color. Clusters of bright punctate fluorescent signal glowed against the dark background, revealing a pattern of protein activation she had never observed. Instead of the diffuse haze she'd anticipated, distinct nodes of intensity traced a pathway from the cell membrane inward toward the nucleus. The mistake in antibody preparation had unintentionally enhanced the assay's sensitivity, unmasking a previously hidden cascade of activity. Her pulse quickened. She snapped a series of digital images, careful to maintain identical exposure times and filter settings. Each snapshot reinforced the pattern. A darting network of protein clusters, faint lines connecting them like synapses in a neural circuit. She annotated the images with arrows and intensity scales, then moved swiftly to replicate the result. She repeated the staining, this time following the correct protocol steps, but mimicked the relative concentrations that had produced the striking signal. Again, the cascade emerged in crisp relief. Amina's hands trembled as she opened her experimental notebook. She sketched the pathway, labeling kinases and cofactors implicated by the signal pattern, and jotted hypotheses. Perhaps this protein complex formed transient microdomains that structured cellular response to stress, a mechanism overlooked because standard protocols washed over these ephemeral assemblies. She consulted her digital library, scanning recent publications for any mention of similar observations, finding nothing. The novelty of the pathway shimmered before her like a promise. Driven by adrenaline, Amina dove into quantitative assays. She harvested parallel plates, lysed the cells, and ran Western blots to validate the presence of key cascade components at the predicted activation times. Pipetting under the lamp's bright glare, she loaded gels, transferred proteins to membranes, and probed with freshly ordered antibodies. Each band that appeared at the expected molecular weight and time point confirmed the cascade's existence with biochemical rigor. As dawn's first light crept through the blinds, Amina sat back and reviewed her compiled data. Fluorescent micrographs documenting spatial patterns, densitometry curves from Western blots, time course charts illustrating the cascade's kinetics. Her makeshift apartment lab had delivered a genuine breakthrough. With a quiet exhalation, she typed an email to her startup sponsor. A concise summary of her findings, attached with preliminary figures, and a request for additional funding to explore the pathway's therapeutic potential. In that fragile electric moment, her lone mistake distilled into the spark of discovery, Amina realized she had unlocked the door to a mechanism that could revolutionize treatment for the very syndrome she sought to cure. And she understood that serendipity, guided by a scientist's persistence and rigor, could indeed rewrite the script of medical possibility. Viscazali, by mid-morning the next day, Amina found herself standing in the cavernous lobby of Accelerate Bio, a modest biotech incubator housed in a refurbished warehouse on the city's industrial fringe. The marble lobby had been replaced by concrete floors and exposed ductwork, but bright banners proclaimed, "Innovation lives here." Armed with her freshly generated data and a stack of printed slides, she joined a line of hopeful entrepreneurs waiting to present at the monthly Pitch and Partner event. When her turn arrived, Amina stepped onto the makeshift stage, a handful of plywood planks and a flip chart, heart pounding in her chest. The audience of investors and scientists circled her in a semicircle under harsh fluorescent lights. She took a deep breath and began, "Good morning. I'm Dr. Amina Patel, and I've discovered a novel protein activation cascade in pediatric patient cells that can be targeted to reverse the progression of X syndrome. Tonight's unintended antibody protocol tweak revealed spatial microdomains we can exploit to design a next-generation gene therapy vector." She clicked to her first slide. A series of high-resolution micrographs, fluorescent nodes glowing like distant galaxies against inky backgrounds. Faces in the crowd leaned forward, investors murmured. She moved on to time course graphs showing kinase activation over minutes, then to a Western blot confirming key pathway proteins, each bullet point building her case. Finally, she laid out her ask, a $50,000 seed grant to outfit a formal garage lab and fund 2 graduate researchers for 6 months of validation and preclinical assays. Silence settled as she concluded. Then applause rippled through Accelerate Bio's audience. One of the incubator's directors, a lean woman in her 50s with keen eyes, stepped forward. "Your data is compelling," she said, voice measured. "We're prepared to offer you a $60,000 pilot grant, plus lab space here in Garage Suite 12. Amina felt her chest loosen, relief washing over her in a warm tide. Within a week, she had signed the rental agreement for a 300-square-foot garage lab behind the incubator's main building. The space, with its corrugated metal walls and fluorescent strip lighting, was rough around the edges, but to Amina it felt like a launch pad. She and her two new hires, graduate students Maya Singh and Carlos Alvarez, spent the next days assembling benches, calibrating a second-hand incubator, and unboxing borrowed equipment: a high-speed refrigerated centrifuge, a microplate reader, and stacks of sterile consumables. Amina taped her project plan to the back wall: weekly goals for assay replication, a timeline for animal model collaborations, and a map of reagent orders. Maya set up the fluorescence microscope on one bench, while Carlos laid out protocols for CRISPR-based validation on another. They mapped out reagent stocks on a whiteboard: primary antibodies arriving Wednesday, gene editing vectors cleared for delivery Friday. That evening, Amina took a moment to walk the length of the lab. The faded hydrochloric acid safety poster on the wall, the hum of the centrifuge, and the scent of ethanol swabs all felt like triumphant markers of progress. She ran a hand along the plywood work surface, recalling its previous life as a palette knife station for a furniture maker. Now, it would stage the experiments that could change medical history. As she flicked off the lights and locked the heavy metal door behind her, Amina understood that this humble garage lab, born of necessity and seed funding, had become the crucible for her boldest scientific ambitions. The Foundation's rejection had driven her here, but tonight, under the hum of neon and with her team poised at the benches, she knew her true research journey was only just beginning. Late one crisp autumn morning, Dr. Amina Patel arrived at Crestwood Children's Hospital carrying a stack of consent forms, patient charts secured in a leather satchel, and vials of her investigational therapeutic vector chilled on ice. The hospital's pediatric wing, once notorious for its sterile corridors and tearful waiting rooms, now hummed with cautious optimism. Pastel walls bore hand-painted murals of smiling animals, and nurses greeted families by name as they passed. Amina paused outside room 312, where 5 children, ages 3 to 7, awaited their first dosing. Each child had been diagnosed with X syndrome, a rare genetic disorder that deprived them of essential enzyme function, leading to progressive muscle weakness and developmental delays. Parents hovered at the door, faces drawn with both hope and fear. Amina knelt to meet them at eye level, laying out the day's protocol in gentle but precise terms. An intravenous infusion of her gene therapy vector, followed by 6 hours of monitored observation, then weekly follow-up visits to assess safety and early efficacy markers. Inside the room, the children clung to stuffed animals or thumb-sucked, their wide eyes flicking between the bright infusion pumps and Amina's calm presence. She introduced each team member by name: Dr. Singh, the pediatric neurologist, Carlos Alvarez, the clinical research coordinator, and Nurse Williams, whose soft voice and practiced hands would handle every line placement. As Nurse Williams prepared the IV lines, Amina donned sterile gloves and double-checked dosages calculated to each child's weight, ensuring the viral particles remained within the tight therapeutic window she had determined in preclinical studies. The first child, little Maya, lay supine on the bed clutching a teddy bear. Amina stroked Maya's arm and whispered encouragement before Carlos opened the infusion bag. The clear solution flowed gently through the tubing, its slow drip audible in the hush. Outside, parents exchanged tense whispers. Inside, Maya's eyelids fluttered as she drifted into calm. Over the next hour, the other 4 children received their infusions in staggered succession, each administration accompanied by careful vital sign monitoring and periodic blood draws to measure vector distribution and immediate immune response. By midday, the infusion phase was complete. Amina convened her team in the attached observation suite, a small room with reclining chairs, medical monitors, and a tray of sandwiches for the anxious parents. She reviewed the real-time data, heart rates stable within expected ranges, cytokine panels showing no alarming spikes, and vector copy numbers in peripheral blood reflecting safe transduction levels. A collective exhale rippled through the team as preliminary safety thresholds held. Over the following weeks, Amina's schedule became a tapestry of clinic visits, lab analyses, and regulator consultations. Blood samples drawn at days 7, 14, and 28 were assayed for enzyme activity, a direct measure of the therapeutic's impact. At first, enzyme levels crept upward in a handful of patients. By week 6, 3 children exhibited near-normal enzyme function, their muscles responding with renewed tone. Physical therapists reported milestone breakthroughs. Children who had once struggled to stand unassisted now took tentative steps, their laughter echoing down the hallway. One afternoon, Amina stood in the hospital's physical therapy room as 7-year-old Carlos Davis reached out to grasp a weighted bar, an exercise he had once found impossible. Tears sprang to his mother's eyes when he lifted himself into a standing position, and Amina felt her own chest tighten with joy. She crouched beside Carlos, adjusting his grip and offering praise. "You're doing great, strong and steady." His grin was radiant enough to outshine any fluorescent light. Throughout the trial, Amina meticulously documented adverse events, minor fevers that resolved within hours, localized injection site redness, and transient fatigue. Each instance was logged in her database, analyzed against control cohorts, and reported to the Institutional Review Board. No serious adverse events occurred. By week 12, efficacy data coalesced into an undeniable narrative. Amina's gene therapy cascade not only arrested disease progression, but initiated functional recovery in a majority of the young patients. At the final study meeting held in the hospital's sunlit conference room, Amina presented her comprehensive findings to a panel of pediatric specialists, regulatory officers, and patient advocacy representatives. Detailed charts illustrated enzyme activity curves rising above baseline, motor function scores improving by 40% on average, and quality-of-life surveys reporting marked gains in independence and joy. The head of the review board, Dr. Mayer, nodded solemnly as he closed her report. "Dr. Patel, your trial has surpassed its primary and secondary endpoints with exceptional safety and efficacy profiles," he announced. "Your work represents a paradigm shift in treating X syndrome. We'll be moving forward with fast-track approval applications immediately." Relief and exhilaration washed over the room. Parents embraced the medical team. Nurse Williams dabbed at tears, and Amina allowed herself a deep, unguarded breath. From the cramped apartment lab to the crowded incubator pitch, to here, this triumph was born of relentless nights, imperfect experiments, and unwavering belief. As she packed her laptop and notes, Amina understood that tomorrow the scientific world would take notice. But today, her reward was embodied in the joyous faces of children poised on the threshold of renewed life, proof that determination, guided by discovery, could indeed rewrite medical history. ChatGPT's Kazal, the press release landed on Dr. Patel's desk early that Friday, its subject line stark and impossible to ignore. Global Health Foundation Awards, Fellowship to Dr. Amina Patel. She leaned back in her office chair, coffee cup trembling in her hand, and reread the opening paragraph. In light of the groundbreaking preclinical and clinical data published by Dr. Amina Patel's team on a novel gene therapy pathway for X syndrome, the Global Health Foundation is pleased to award Dr. Patel the $500,000 USD Fellowship in Translational Medicine, effective immediately. Her heart thundered. After 2 years of solitary lab nights and a waitlisted grant application, the very institution that had dismissed her work was now extending its largest award, retroactive no less, to the scientists they once deemed below threshold. She grabbed her phone and dialed the fellowship coordinator's number before the room stopped spinning. On the other end, A warm voice offered apologies for the Foundation's earlier oversight and congratulations on her well-deserved recognition. Dr. Patel felt both vindicated and wary. Institutional backing now meant access to state-of-the-art facilities and resources. But it also raised the specter of lost time and the bias that had nearly derailed her career. Within days, she signed the official fellowship agreement in the Foundation's gleaming boardroom, surrounded by polished mahogany and portraits of past laureates. The Foundation president, Dr. Elena Cairns, stood to address the assembled staff and media. "We are humbled by Dr. Patel's accomplishments and regret our initial decision. Her work exemplifies the scientific rigor and humanitarian spirit we aspire to support. We welcome her to our fellowship family and look forward to accelerating her therapy from bench to bedside." Amina nodded, the weight of her journey settling around her like a mantle. As cameras flashed, she mentally mapped out the next steps. Integrating her apartment-born data into the Foundation's high-throughput screening platform, recruiting a full team for expanded preclinical models, and launching multi-center trials with international partners. Back in her new Foundation-sponsored lab, floor-to-ceiling windows overlooking a manicured research quad, Amina unpacked boxes of reagents, lab notebooks, and fresh pipettes. The humming incubators here were whisper-quiet compared to her past second-hand models, and the mass spectrometer gleamed like a polished sculpture. She taped a small handwritten note to the whiteboard. "Thank you for the second chance. Now let's save lives." Over the following weeks, her team expanded to include bioinformatics specialists analyzing gene-editing off-target effects, pharmacologists optimizing delivery vectors, and clinical liaisons coordinating with pediatric hospitals worldwide. Weekly strategy meetings replaced solitary nights, but Amina preserved her ritual of ending each day under the soft glow of her desk lamp, reviewing data, formulating next-day experiments, and mentoring a steady stream of graduate interns. Meanwhile, news of the fellowship reversal sparked broader conversations in scientific journals and social media about equity in grant review processes. Editorials lauded Amina's perseverance. Symposia invited panels on unconscious bias in funding, and the Foundation itself announced reforms to ensure diverse voices would influence future award decisions. One crisp morning, as Amina entered the Foundation's central atrium, she spotted her mentor, Dr. Morales, whom she hadn't seen since her garage lab days. He greeted her with a proud embrace and then led her to a small plaque mounted near the lab's entrance, inscribed with her name and 2019 Rejected Fellow, 2021 Laureate. "This will remind us all," he said softly, "that brilliance often emerges from unexpected places, and that institutions must remain humble enough to change course when confronted with new evidence." Amina touched the cool metal letters, her eyes bright. From a lone researcher in an apartment to a Foundation-backed fellow directing a global research effort, her path had come full circle. The fellowship reversal was not merely a personal triumph. It was a testament to the power of persistence and the imperative that science, above all, remain open to the voices it once silenced. The morning of the International Regulatory Approval Ceremony dawned clear and crisp, the pale blue sky above Geneva reflecting the buoyant hopes of countless families affected by X syndrome. Dr. Amina Patel stepped onto the terrace of the Palais des Nations, her heels clicking against the broad marble expanse as delegates from around the world gathered beneath fluttering flags. Behind her, a banner proclaimed Global Approval of X Syndrome Gene Therapy, a new era in pediatric medicine. Amina glanced at the lineup of dignitaries. Heads of the World Health Organization, representatives from the European Medicines Agency, patient advocacy leaders from 5 continents, and veterans of the Global Health Foundation, all assembled to witness the culmination of a journey that had begun in a cramped apartment lab. She adjusted the lapel of her tailored jacket, the pin bearing her fellowship insignia gleaming beside her heart, and inhaled deeply, tasting cold mountain air and the promise of change. Inside the grand assembly hall, vaulted ceilings and ornate chandeliers cast a warm glow over rows of polished wood seats. Amina took the podium, her speech meticulously crafted but heartfelt in every line. When she began, her voice carried clearly through the hushed auditorium. Distinguished guests, colleagues, and most importantly, families whose lives have been touched by X syndrome, today we stand at the threshold of a new paradigm. 2 years ago, this therapy was an untested hypothesis arising from a serendipitous lab discovery. Today, it is an approved standard of care, changing the course of childhood for thousands across the globe. She clicked to a slide showing pre- and post-treatment MRI scans. Muscle tissue density restored, neural connections reinforced in young patients once destined for progressive decline. The images drew gasps and nods of approval. Amina continued, detailing the rigorous trial results: 60% reversal of key developmental milestones, 0 serious adverse events, and quality-of-life metrics matching healthy controls within a year of therapy. As she spoke, a stream of gratitude flowed through the audience. A mother in the front row dabbed her eyes with a handkerchief embroidered with her daughter's initials. A pediatric neurologist from Argentina leaned forward, lips parted in awe. Somewhere in the back, a policymaker took vigorous notes, already plotting equitable distribution channels for low-income regions. After her address, delegates rose in a resounding standing ovation. Amina returned to her seat amid the glow of united acclaim, her chest alight with the knowledge that her perseverance had rewritten medical history. The Director General of the WHO took the podium next, formally endorsing the therapy and invoking the Patel Protocol as a model for accelerated pathways in rare disease research. Shaking Amina's hand, he remarked, "Your journey from rejection to revolution will inspire a generation of scientists." In the days that followed, Amina's schedule became a whirlwind of press conferences, roundtables on global access, and meetings with health ministers. Yet each evening, she returned to her Geneva hotel room and paused before a small photograph pinned to the bulletin board. A grainy snapshot of her apartment lab, the desk lamp illuminating her lone figure bent over a microscope. She smiled at how far that solitary seed of inquiry had grown into a worldwide forest of healing. Several weeks later, Amina received an invitation from the foundation that had first turned her away. They requested her presence at their global symposium in Basel to deliver the keynote on equity and excellence in scientific discovery. Before departing Geneva, she penned her speech on the train ride through rolling vineyards, an honest reflection on bias, a call for inclusive review processes, and a tribute to every underfunded researcher laboring in obscurity. When she stepped onto the Basel stage, the audience rose again, not just in celebration of her success, but in recognition of the collective effort it represented. Amina spoke with the calm authority of experience. Let this therapy's approval remind us that brilliance can blossom in any corner where curiosity meets opportunity. May we build systems that welcome every promising idea so that no gift of science is lost to oversight. For in the unity of purpose and the generosity of support, we find not only cures, but the true spirit of progress. As the final notes of applause faded, Amina looked out at the faces before her, researchers, funders, patients, each one a thread in the tapestry of change she had helped weave. In that moment, she realized her journey had become more than a personal odyssey. It had sparked a movement toward a future where every rejected idea might one day find its place under the healing light of discovery.